So piecewise functions. Some functions are defined by different rules in different parts of their domain. They're called piecewise functions. Because of the different rules, there's an opportunity for the function to be discontinuous at certain points. So we need to sketch the graph. In order to sketch a proper parabola, what should we find? Starts with a V, rhymes with a vertex. The vertex, thank you. So how do we find the vertex? Mackenzie didn't need that. He had it. He was all over it. He didn't need no rhyming. In the whatever form, yes. The completed the square form. Okay, so everyone right now, take x squared minus 2x plus 1 and put it in completed the square form. Plus blank minus blank. Okay, so we get x squared minus 2x plus 1. So we go bracket 1 x squared minus 2x plus blank minus blank plus 1. To get our blank, we do b divided by 2 squared. So negative 2 divided by 2 squared is negative 1. Squared is 1. The 1 stays. What multiplies give me 1 and adds give me negative 2. X minus 1 twice. So x minus 1 squared. Then you'd have to remember to multiply these, but because it's a 1, it doesn't affect it. But if it was anything other than a 1, like a negative or 7 or something, it would. Then we get negative 1 plus 1 is just 0. So you could put a plus 0 at the back, or you don't have to put anything. So my vertex is at 1 and 0. Now we have to decide, is that even in the domain? Yeah, Nick?
If the 1 was a negative 1, would you minus 1 the bracket plus 1?
If this was a negative 1 here?
No, the other.
This one?
Yeah, that was a negative.
It's always going to be a positive. Because you're squaring it. Yeah. If this was a negative, though, it would cause this to be positive, and then you have to do it. Yeah, but this will always be positive because you're squaring. So we have to decide, is 1, 0 in the domain? Our domain is less than 1. Technically, it's not, but we have to always state right up to this point, remember, but we just put an open dot. So we actually always have to find the x value for this graph at 1 and the x value for this graph at 1, but we just close or open dot depending on if it's greater or if it's equal to or not. But you need to find the value at 1 for both of them, because that's where your graph is going to reach up to, okay? It's just not including it. So we do know that 1, 0 is where this starts. It's just that it's going to be open. And then we have to go that way, right? So we need to find values on the left of it. So I'm going to do 0 next, then negative 1, negative 2, or whatever, till I get enough points to graph the rest of the graph. Because I don't want to go this way, because this graph only is representative of when the domain is less than 1. So do a table. What? X squared minus 2x and x. So we have 1 already. I'm going to do 0 next. So it's going to be 0 squared minus 2 times 0, which is 0. Oh, there's a plus 1. I just didn't put it. Nice. 1. I'm like, that doesn't even make sense. It physically cannot do that. Well, I'm like, it's a parabola. It doesn't go horizontal. So, there's a plus 1 at the back. Too much blue going on here. Then we fill in a negative 1. Negative 1 squared is 1. Minus 2 times negative 1 is 2. Plus 1 is 4. It should be going down here, but my smartboard's as well. That. So on the left, it looks like a parabola. On the right of 1, it looks like a line, right? So the very first one I'm going to start at is x equal to 1, because that's where I start, and then I get bigger from there, right? So when I plug in a 1, I get 3 minus 1, which is 2. So at 1 and 2, I have a closed dot. Because it's equal to 1 for this equation. Then I pick values bigger than it. So 2. 3 minus 2 is 1. So my next point is going to be at 2 and 1. I could just use the slope from now on if I wanted to, right? Down 1 over 1 would get me to the next point. That would be the sketch. So this function f of x looks like this. On the left, it makes a parabola. On the right, it makes the line with negative slope. So the key thing when drawing piecewise functions is always find the value that these are for each function first, because that's where it's going to come up to. And then find values on the left of it and on the right of it to find the rest. So this is where it gets a little complicated. It's a sketch, right? So can everyone's be a little bit different where the end values don't like show us where they go? Yeah, our arms could go differently on the end. But there are some distinct things that have to happen. So when I sketch a graph with this information, the very first things I sketch are the points that are for surely there. So 0 and negative 1 is there, and 3 and 1 is on this graph, right? Because functions are just another way of saying coordinates. So here, this is the point 0, negative 1. This is the point 3 and 1. Now, something else we know for sure is that on the left of 0 and on the right of 0, it's approaching 1. It has to be because it has the limit as x approaches 0 is 1. So that means on the left and the right, it has to both be approaching 1, or this would be it does not exist, right? So I know at 1, it's approaching from the left and the right. Now, would this be an open dot or a closed dot? There's already a closed dot. So what would have to be open? Now, from the right and the left, it's approaching that. So somehow we have something coming into here, some value, some type of graph that's coming into that, right? I'm just drawing little tiny pieces because I don't know exactly where they're heading, but I know that there's something coming in from the left and something coming in for the right at that value. I'm just drawing little ticks for now, so I know more. Now, from the left of 3, this graph is approaching negative 2. So on the left of 3, this graph is approaching negative 2. There's already a value at 3, so I'm going to do an open dot. And from the left, there's a little intake, something coming in here. That's going to approach that from the left, right? From the right of 3, it's approaching 2. So coming in from the right, it's approaching 2. How could this graph be drawn? Well, there's nothing on the left other than this, right? So could I come up to it like this, like a parabola coming into it? Yeah. Could I come down to it? Yeah. Could I come straight across into it? Yeah. Are any of those more correct than the others? No, they didn't specify anything. So I'm going to be cool and come straight in. Could you have a parabola coming down or a line coming down or a line coming up or a parabola? Yes. You just have to, from the left, come to that point. Because this is coming in from the left here and this is coming in from right here, I'm going to make them connected. I'm going to go like this. Could I do a little curve between them? Yes. I'm going to do a straight line. Yep. It could. But because we need to have some sort of graph coming into it, usually they'll connect these two. And then this one here has to have something coming into it. So I could come down with a parabola. I could have a parabola coming down like this. I have a straight line coming in. I could have another horizontal line going out. It doesn't matter. I just need to have something coming into it. So I'm going to do a curve down. So those two arms at the end could totally look different for every single person, right? With the information they gave us. Now, what they can sometimes do in order to make it a little bit more specific is they can say on the left of 0, they can say it's approaching negative infinity or something like that. Well, that wouldn't work. They'd have to do ends. They'd have to say as you approach negative infinity, the graph approaches negative infinity. Like they'd have to go the limit as x approaches negative infinity, which means this way, it approaches negative infinity. And then that would tell you that the graph would have to go down or something like that. Or they could say as the graph approaches negative infinity, it approaches positive infinity, and then it would have to go up. That's another way they can make it a little more specific so that everyone's kind of has to be similar. Okay. Let's look at B. Try it out. So for this one, I would first plot 0, 2 and 4, 1. So on the left of 0, it's approaching 2. So I go to 0, 2, it's approaching 2. Oh, good. Oh, great. Left, it's approaching 2. Still off. It's approaching 2 from the left. Imagine that. This is great. I love smartboards. And then on the right of 0, it's approaching 0. I'm going to do an open dot at 0, and from the right, it's approaching it. So I'm just going to do a little dash in so I know that it has to come from the right to get to that point, right? Left of 4, it's approaching 3. So somewhere in here, it's coming from the left. And the right of 4, it's approaching 0. So I'm going to go like this, coming in like this, just because I feel like it, not because it's correct. You could be coming. It's completely colored in because this would be a closed dot, 0, 2 would be a closed dot, and then the limit would have an open dot, but the open dot would look like this, and then the closed dot would look like this. So it technically fills it in. Over top of it, yeah. It's not wrong, but it'll fill it in. Yeah. So the moment you have a limit that actually approaches a dot, the dot filled in trumps the open dot of the limit, if that makes sense. And then we need to go from the left to the right here. So I'm going to go like this. You could make it curve a bit if you wanted to. And I'm going to go like that because I feel like it. Could have went straight out. Could have went down. Could have made a squiggle. I don't really know. Whatever you want. Yeah. The open dots, you have to connect somewhere in the middle for sure, because if not, nothing's coming from the left and coming from the right. So if I didn't connect these at all to anything, then nothing is actually coming from the left, which is telling me something coming from the left. I guess, if you had, like, you could make yourself have an asymptote in the middle, but then they more so would specify there's an asymptote in the middle. Yeah. All right. Limits using tables. Longest way to calculate limits. This is the longest way known to math. So it's always everyone's like backup. Like if you have no idea how to calculate a limit, you can do a table of values on the left side and right side and see what they're approaching. Is the longest way to do it because you're filling in like 0.000 for every x and 0.00000 for every, like 1 for every x, right? You're adding that little 1. So let's see. So when it's approaching 0, you can actually do a table together. I'm going to show you left side, right side anyways. So this would be left side. Oh, it's getting worse. And then this is going to be right side. This is x. And this is the limit as x approaches 0. Technically, I guess you don't need that part. You need tan 3x over tan 5x. So this can be x, and this can be tan 3x over tan 5x. So from the left as your approach, equals y. No, it just equals y. So what we're doing with the table of values is we're picking x values that are going to get closer and closer and closer from the left to 0 and see what it's approaching. And then we're going to pick the x values and see closer and closer and closer from the right and see what they're approaching for the y values. And if they approach the same thing, then the limit as x approaches 0 of that is that answer. So we just have an x, and this is just our y. We're just finding the y's right now that correlate with this part. So from the left side to 0, you could go negative 0.01, let's say. That's getting closer to 0, right? And then you could do negative, and a lot of people go 0, 0, 1, 0, 0, 0, 0, 1. But because I'm lazy, I'm going to increase really fast. Okay? So negative 0.01, and then I'm going to go 0.0001, and then I'm going to go negative 0.0000001. Let's skip the ones in between, because technically once you get to here, you're kind of seeing pretty accurately what you are close to 0. So you can go to your calculator and you're going to go tan bracket 3 times negative 0.001 divided by tan 5 bracket negative 0.001.